Man, your son's stuff is over there.
tinyurl.com/tools for math, and then tools for math. Let me know if it works for you. Did it work? Perfect. Excellent. tinyurl.com.
Did you leave it over in the bar? We went to go get a drink. Can you turn that down?
Oh, should I turn it off?
No, I want some air.
Oh, sorry.
You not hot? Oh, I forgot you.
I'm from Texas.
Yeah, you want to be hot. That's how you like it. I'm like, man, I'm dying over there.
So we'll just go for about 20 minutes. And then, so I made a link for all of us. You guys see it says tinyurl.com/toolsformath123. So since you guys came out and you came ready to work, you guys get a free copy of my book. That's a PDF, free copy of Tools for Mastering Mathematics. And it's basically going to tell you some of what I shared with you today with a few more strategies. But I really want you to just take it in. And then, is this Sana? Is that right?
Yeah.
Sana? Okay, Sana is a mathematician too. Yes. So she can double check my work and let me know if there's any things we need to tweak. But this is tinyurl.com/toolsformath123. Let me know if you guys have that PDF. And let me just explain what the PDF is. Have you guys ever heard the saying, don't give a man a fish, teach him to fish? Have you guys ever heard that saying?
Yeah.
Okay, so I'm gonna teach you to fish today. I've given you some fish, but I want to teach you to fish. And part of teaching you to fish is this book, Tools for Mastering Mathematics. And here's what I did in the book. I did 3 things. About 15 years ago, I found a problem. I called it the American math problem. What was the problem? The problem was that I was teaching in the summer of 2012, and I realized that the algebra book, the geometry book, and the algebra 2 book had a lot of similarities and a lot of repetition. Now, why is that a problem? Because a lot of kids who had finished algebra 2 were still not very good at math. Then I realized that's a problem. Repetition does not lead to mastery alone. You need to learn you need to master the thing and not just think, I'm just going to try it again and again without a plan. So then I decided to do something. I said, what if I take all the topics in math from kindergarten to 12th grade and put it into one book? So that's what I did. So my books actually take you from, like you just heard what math was yesterday, to calculus in less than a year. So 11 years of math in one, if you want it, right? Or you could do it in 2 years or 3 years. That's fine. But at least you're doing it condensed. Right now we do it in 12 years. And where does our nation rank? Number 38 in the world in math, by many standards. It's nothing to write home about. So that's my solution is, let's fix this problem by teaching kids to master math. So I wrote it in that book, Tools for Mastering Mathematics. What I just told you is the third part of my book. Does that make sense? There's 3 parts. The third part of the book shows you all the topics, every topic you need to know, literally, to be ready for calculus. The first part of the book tells you how to be good at math, right? There are some strategies. But the second part of the book is what matters to you guys here today. Because in the second part of the book, I talk about the rules of exponents. I talk about the rules of radicals. So can we just run through some of these rules quickly so that when we use them, they're easy? Are we ready? What's the very first rule? If you have the same base and you're working with a number, if you have the same base, you can add their powers. Everybody see that? That's the first rule. The second rule is if you are dealing with the same base and you have different exponents, you can subtract their power. Okay? The third rule I'm going to give you is just that anything to the power of 0 is 1. Okay? So we have these rules that we can keep in mind. We also have a rule like this, right? Again, we're going to do some practice problems, but I just want to set the stage a little bit. So the fourth rule is that if you have a power, you can multiply the powers, right? Okay, so that's the fourth rule of exponents there. But there's one rule of exponent that is kind of interesting, and I'm actually going to write it as a fractional exponent first. So x to the power m over n is the same thing as the nth root of x to the m power. So that is called a fractional exponent on the left, and on the right is called a radical. You can change fractional exponents to radicals, and you need to be comfortable doing back and forth. Everybody get that? You need to be comfortable going back and forth. Okay. What about if I have x over y with an m outside? Well, I can write it like this. But what if I have it like this? Then I can write it like this. And then lastly, what if I have it like this? I have it like that. Okay, I know that's a lot. I just want to give you the rules. We got the rules now. We can use the rules, right? As we need to. So those are called the rules of exponents. There's also something called the rules of radicals. And we have the rules of radicals in the book for you. And we have the rules of logarithms or the laws of logarithms. Those are all going to be critical. This is one of the key ones that you guys might have seen. Okay, I'm just going to put it like this. The base raised to the power will equal the answer, essentially. Guys, this is just to give you a nugget. We'll come back. But I just want you to remember, math is like, how many people have used, I'm sorry, I just have to use this quick example. How many of you have used agentic AI or AI tools that have agents? Okay, so when you ask an agentic AI to build you something like a website, look at what the AI types in a little bit. Here's what you will see, something like, if I'm going to build a website, I need to find these skills. So let me go find the skills. It will say that, like something like that. Let me go find the skill. Okay, I need a skill. I need a React JS. I need a JavaScript. I need a... Okay. Mathematicians, in a way, are like that. They're like, I solve that problem. Okay, what do I got? I mean, the same thing with engineers or people who fix airplanes, make aviation mechanics. What do they need to do first? Let me check my tools. Okay, I got... Does that make sense? So what's in your toolkit? Does that make sense? What's in your tool? You need to know the rules of exponents, so you pull them when you need them. You need to know the rules of radicals. So let's talk about the rules of radicals for a second. And I'm so sorry, I know I'm writing quick on the board, but I know your program only goes till noon, but by God's grace, I mean, if Mr. Silas is okay, I'll come back. You just let me know, and it's just a direct flight from Austin to you guys. Okay, that's where I fly out of, is Austin. Okay, so then the next thing is the rules of radicals. Are we ready? Let's just look at a couple of them. So with radicals, if you have something like the square root of mn, you could write that as square root of m times square root of n. Why does this matter? Because sometimes it is better to decompose the radicals. Does that make sense? Sometimes it's better to decompose the radicals. The same rule applies when you have this, right? And of course, n cannot equal 0, right? Why can't n equal 0? It was undefined if you have a 0 in the denominator. Okay, so that's the rules of radicals. We already talked about the fractional exponents. We talked about the rules of radicals when you're multiplying them like that. Let me give you a quick question. What happens if someone asks you square root of 32 plus square root of, let's say, I'm not going to go with 64. I'm going to go with 128. How about this? What do I need to do now? How do I add two radicals that don't have the same thing inside? What do I need to do to the numbers inside the radical first? Everybody's got it at this point. Prime factorized, right? That's like I gotta get a t-shirt, prime factorized, right? That's so basically this is 2 times 2 times 2 times 2 times 2 plus 2 times 2 times 2 times 2 times 2 times 2 times 2. I was sitting out there in Lagos, Nigeria, and this is what we used to play with in 1997. We used to do stuff like this. So you take the numbers, you break it down, right? So this part becomes 32, 64. I added one more, my bad. So 32, oh, no, I was correct the first time. What am I doing? Mr. Silas was looking on the board and I thought I wrote more than one. So one more. I'm like, okay, so what's 2 times 2? 4 times 2, 8, 16, 32, 64, 120. I was correct, okay. Don't question yourself sometimes. I'm kidding. It's okay to question yourself. You know, one of the things that happened to Albert Einstein at the end of his life, he was wrong on something. Well, actually, earlier on in life, he was right about something and then he doubted himself. And then he found out later he was correct when he was trying to do his theory of general relativity. And then later on in life, he was wrong about something. And then he remembered, potentially, I think he remembered the time when he changed, and he didn't change, but he was actually wrong this time, right? So sometimes you got to just know humility. So guys, when you leave here today, I want you to take this to your friends. Ask them, you going to make me a better person or not? If they say, nah, we're just going to keep hanging out where we are now. Tell them, our friendship is done. Moving on. Does that make sense? If your friends are not making you better, you're done. I'm serious, you're done. There's no time to remain where you are. You need to challenge one another. Does that make sense? You look at those basketball players, a lot of these guys who are doing really good. Do you think they just let themselves stay where they are? They're getting better. Why can't we be getting better, right? So anyways, moral of the story, sometimes you're going to be wrong, be humble, okay? Take correction. So in this case, you can take out this 2 and you can take out this 2, right? So you have 2 times 2 square root of 2. Think of it like coming out of the radical is like coming out of prison or jail, right? In a sense. I'm like, I want to get out. And then the radical conductor says, you can't come out until you meet the criteria. What is the criteria? In this case, it's a square root. Everybody see that? What is a radical without a number written? It's a square root. And then you could take out this 2. You could take out this 2. You could take out this 2. So this is plus 2 times 2 times 2 square root of 2. Guess what, guys? The fact that they both have the same radical and radicand and index means that I can add them together. So this 2 is going to be 4. This is going to be 8. So this is 8 square root of 2 plus, they have 2 times, 4 square root of 2 plus 8 square root of 2. That's what I meant to say. What is 4 plus 8? So 12 square root of 2. Guys, haven't you seen something like this before where you're adding like terms? But that's the same reasoning. I don't know if you guys are beginning to see what I'm trying to get at. The methods of reasoning are sometimes more important than just the topic. You need to know how to reason. So that's why you fundamentally do mathematics. What does it do to you? It teaches you how to reason. Does that make sense? So this reasoning for like terms is the same reasoning for adding radicals. That means if you just have a certain set of tools in your pocket in math, you can derive anything else. You just gotta have them in your pockets. Okay, let's go over to my ACT questions. I have a few questions here. I'm just gonna grab a couple and then I'll land my plane. Before I go on, questions, thoughts, comments, objections on anything on any ACT math domain that comes to mind.
I would say that I love, like, when I'm doing these problems, I love just taking out the perfect square.
Yep.
And that also really good too, to get to your answer really quickly.
So if you know this is going to be 4, right, that's a perfect square. Mr. Silas just opened a can of worms. It's not my fault, but I'm going to do this to you all. Are you guys ready? Quick activity, everybody. X squared, x cubed. We need to know our squares. There is no way around it. Everybody see this? I'm going to go down to 15. Everybody, please, can you write 1, 2, 3, 4, 5, 6, 7, 8, down all the way to 15? And we got to square them. Why? Because you got to see the squares. They have to be automatic. Does that make sense? So all your squares, please. So, you got your squares.
I know.
And let's keep going all the way to 15. And then if you don't mind, get me your cubes all the way to 6 for now. But later on, please complete it to 15.
I'm okay.
Yeah.
Okay, let me... So we need our perfect squares and perfect cubes. For those on the call, how many people are comfortable with maybe typing in some perfect cubes? Can you give us some perfect cubes on the call? Since you guys are on the call, we'll give you the harder questions. Can you tell us the cubes in the chat? Why does this matter? Well, you'll see why, right? I already wrote a problem down that shows you why it matters, right? So we need to know our perfect squares because of the difference of two squares. And we're going to give you the formula for the difference of two squares and the difference of two cubes. So you need to know the difference of two squares, the difference of two cubes, and the addition of two cubes. Thank you, Eric. It says 4 times 4 times 4 is 64. It's perfect. Oh, 1 second. Let me go here. And then we need 3 times 3 times. Okay, got 27. Okay, it's trying to get some participation here. Very good. So then if they ask x cubed minus 27, we need to know what that becomes. And then I'm going to switch gears. We're going to talk about mean And thank you, Cameron. 5 times 5 times 5. Very good. And then we're going to talk about mean, median, mode, just for a quick second, because that is actually the first question on the ACT exam I have right here. The first question is about the mean, so we need to just do a little bit of review of that. Once you're done with your, thank you so much. Once you're done with your squares and your cubes, please save that page. Everybody, make sure you know your squares and cubes. And then let's try these 3 problems. 1, 2, 3. So now we're going to apply the principle. We're going to apply the principle there. Anybody have, are we done with up to 12 times 12? Do you guys get the squares all the way to 12s? Okay. So I'll let you guys finish that later if you don't mind. I want to bring it back home to the question of what is the formula for the difference of 2 squares? A squared minus B squared is equal to A squared, A plus B, A minus B. But that's the same thing as A minus B, A plus B. And why am I putting this here? Because, are you ready for this? I want to introduce the commutative property of multiplication. I also need that to be plain in your mind. Whenever you do anything in math, you should have a reason for why you did it. If you don't have a reason for doing it, like, oh, I just felt like it, oh, it's not going to work. If you build a bridge and I ask you, how did you build it? Did you calculate stuff? You're like, oh, I just felt good. No, I'm not going on that bridge. Does that make sense? You need to explain why. So this is called, you have the commutative property of multiplication. Does that make sense? Does everybody know the distributive property? Everybody know the commutative property, the associative property, the identity property, the inverse property? Guys, these are the things you want to be playing around with. Again, I'm not saying you shouldn't have a life, okay? You can have a life and do math and all that.
This is life.
This is a yeah. So I'm telling you this. This is like you're investing in your future. Know these things well, master them, and teach. You know, one of the best ways to learn is teaching to somebody else. Does that make sense? And maybe sometimes your parents might not want to sit down and listen to a math lecture. Why don't you just record a random YouTube video then teaching? You know, send me the video. I'll watch. Right? You got one viewer. So
well, let's go at 30 and work for $530.
So that's excellent. Well, I know that I'll take a quick 1 minute and just write down the difference of 2 cubes, and then I know if you have to leave, just feel free anytime, please. This is going to be this. And I want to just leave you with, so this is the difference of 2 cubes. This is the addition of 2 cubes. And I'm going to tell you how to differentiate between them. And then you have the difference of 2 cubes here. Okay, so guys, these 3 formulas are going to be very important sometimes. So how do we know the difference between the subtraction, the difference of 2 cubes, and the addition? Well, look at the sign in the first parentheses. And then the sign changes as it goes to the second. And then the third part is the same. So I'm just trying to show you, because some people make a mistake with the difference of 2 cubes and the addition of 2 cubes. Does that make sense? Yeah. And the way you need to remember is that there are going to be 2 parentheses. In the first parentheses, it will match up with the difference of 2 cubes. And then in the second parentheses, I have to change the sign as it comes back around. Right? So this is 3 topics you need. Why is this important? Because somebody can ask you this. And guess what this means? Do you guys see how that cancels now? Man, when I cancel that sometimes, I'm just being honest with you guys. Sometimes you just want to cry. I mean, look, isn't that beautiful? Like, the effect. Anybody ever felt that way? Like when you're canceling and you're doing it knowing it works? Like, man, it's a beautiful, oh.
I cry all the time.
So this is what I want you to realize. Like, math is not a guessing game. We're not trying to trick you. There are rules. If you follow the rules, you win. Everybody get it? And it's one of the only subjects where you can literally, you can correct me if you have the, like if you know there's a rule I'm breaking, you can just be like, hey, Mr. Amos, Euclid didn't say that. You can correct, that's fine. Nobody has a monopoly on it. Does that make sense? but you gotta know the reason though. Right? You can't just be telling your teachers they're wrong without a reason. Does that make sense? You have to have a reason. So, okay, let me tell a story and then I'll give you guys the time to decompress. How many of you have heard of Fermat's last theorem? Okay, some 10-year-old kid solved Fermat's last theorem, which is a problem that wasn't solved for like 200, 300 years. And he solved it, but he saw it when he was 10 years old. He had a vision for his life, right? Have a blessed day.
Thank you. Nice meeting you.
Nice to meet you. So he had a problem he had to solve. So here's Fermat's last theorem. We know that a squared plus b squared is equal to c squared. This is Pythagoras' theorem. Can you do this? Is that a thing? Does that exist? Can you do a cubed plus b cubed is equal to c cubed? No, you can't. But that's not the issue. You can never do it for anything greater than n is greater than 2. Pythagoras' theorem works, but there's no two numbers in the world that if you had to cube the first and cube the second, you get the cube of the third. But what makes it crazy is there's actually no numbers ever that will ever do it after a square. That's an audacious claim to make. That was made around 1640. And the guy said, I have a proof for this, but I've run out of room in my paper, so I can't show it. And then he died. The world of math went crazy for 200 years. They're like, we gotta find, is this true? And a small boy from Cambridge, England sees the problem at 10 years old. It's like, I'm gonna solve this. Like, solve this? Yeah. He went on, got a PhD from Princeton, which is one of the best in the world in math, just so you know. And that's where Einstein died. That's where he spent his last years, was in Princeton. That just tells you, Princeton is a serious place. Does that make sense? That guy, in 1994, with all the cameras, all the mathematicians, at Cambridge University, and they're watching him. You got it now? He said, I got the proof. Prove it. And he proved it. It was correct, but there was one minor glitch. He fixed it. All the mathematicians looked at it. He was right. That is true. And it's been proved. It took, he had to come up with new math stuff to fix, and remember, the whole world of math is checking his work. Can you imagine doing math and the whole mathematicians, all the number theorists are following you every step for 200 pages? Isn't that crazy? He was right. I know it sounds crazy, but here's the get. You cannot find any number where n is greater than 2, that this is true. And there's a proof for it. The point I want to bring up in part of this is the guy had what? He had a vision. What was his vision? I'm going to solve this problem. What's your vision? Right? As Mr. Silas and I were talking, what's your why? If you don't have a why, if you don't have a vision, here's what I want to encourage you to do today and in the next few days. Spend more time reading books about your why. Just spend some time. And some of you already know your why. Maybe there's something you want to solve in the world. I want you to articulate that in a document and keep it somewhere. Okay? You have to have your why. And then it helps you to keep pushing when the days are hard. Does that make sense? So what is your why? If you don't have one, talk to some people, get some counsel, figure out what you're trying to do with your life. And some of you are like, well, I'm just 14. I don't need to know. How old was Andrew Wiles when he found this problem? He was 10. I could go on and on with other 10-year-olds. How old was I when I started writing math problems, even though I didn't know that was my why? I was 9. Right? Isn't that interesting? Don't kill your dream because of your age. Go solve some problems. Sound good? So the guy's name is Andrew Wiles. He went on to win the highest math award. And he won the, he's won many awards. I don't think he won the Fields Medal because he was older. There's an award for those who are under 30 in math, which he would have got the Fields Medal if he was younger. But he won other math awards, basically, at the highest level. He was 10 years old and he had a vision. So guys, I know you came here to do math, but I just want to remind you, you got to have a vision. You have to know where you're headed in life, or at least have an idea. And here's why. Let me tell you this, and then Mr. Silas will come back to some problems, but the iPad is going to be dying in a few minutes. So let me do this. I think that, how many of you here know for a fact what you want to do with your life? Okay, how many of you have ideas of what you think you want to do? Can you, I think, write them down in your notebook? Just write down the things that you think you want to do. Okay? So, the reason why I'm telling you to do this is because I was talking to someone not too long ago, and one of the things we realized is if you're headed in a certain direction, but you know where you're going, and then you have to change directions, that's okay, because you will at least have been living a life of purpose initially. Does that make sense? It's not that you must become an engineer tomorrow, even though that is one of the highest fields of return. If you're like, I don't know what to do with my life, well, be an engineer. You'll be okay. You'll be able to feed your family, right? Or a doctor. But the point is, you need to have a direction while you also grow your entrepreneurial skills. Entrepreneurship is no longer optional. It's not an option. If you're not an entrepreneur in the AI revolution, you are in trouble. Do you know why? Because the AI revolution rewards the people that are entrepreneurs. I know people who are doctors, but they're entrepreneurs. I know people who are engineers, and they're entrepreneurs. You have your base, but you're also entrepreneurial. A doctor who is entrepreneurial can start clinics and so on and so forth. A physicist who is an entrepreneur can do things. Does that make sense? So everybody entrepreneurial thinking. So here's my analogy again. What is your goal? Stay focused. I want to be an engineer. I want to be an electrical engineer. Oh, I really love physics. I'm going to tilt. But look what happened from here to there. I had a vision. I was on track going somewhere. I like physics. Oh, I like chemistry. But I'm still on track. I'm doing something. Here's America for you. What do you want to do with your life? I have no idea. I have no idea I don't know where I'm going. Hey, do you see why American students struggle sometimes? They don't go anywhere. Just bouncing around. And here's why that's a problem. Because the adults allowed it. You can't do that in Nigeria. You can't do that in India. You can't do that in Singapore. Every child in those countries has a direction. You have to have a direction. And this is, again, I'll say this and then I'll calm down. Amos, calm down. My heart is just saddened that we're not allowing our children to have direction in our nation. Why? Who benefits? Who benefits from clueless kids? Does that make sense? Nobody, right? And again, I'm not calling anyone out. I'm just trying to say this is a state of emergency. We have the young people confused. Let's solve it by showing them to have a vision. Okay? Back to our regular programming. Okay, so any topic in math that you guys want me to cover before we wrap up? Any topics burning on someone's heart? Otherwise, let me do the mean. Okay, the mean is the number of numbers, right? If I have 5 numbers, divided by the number of numbers. So if somebody tells you, this is the very first question on the ACT, okay? Yes, on the ACT test. They said Cameron took 4 tests. He took 4 tests. And the question is, and his scores were as follows: 100, 60, 30, and 80. And they said he took another test and he scored X. Their question is, the mean score of the 5 tests was 72. So they're asking, what is X? That's literally what they're asking. He took 5 tests and he scored X on the 5th test. We don't know what he scored on the 5th test, but we know that he scored a 70. Do you see? He scored a 72 as an average. Everybody see that? That is his average. So guys, can you solve for X in this? Right? So all we need to do for this one is we're just solving for X. Everybody get that? So let's add all these up. What's 100 plus 60 plus 30 plus 80? Anybody have that? 270? 270? Let me make sure. Okay. You guys, your minds are younger, so your arithmetic's gotta go boom, boom, boom. So then what do I do to both sides? I multiply both sides by 5, right? Why? Because that's how I get rid of the 5 in the denominator, right? And so then I have 270 plus X is equal to what's 72 times 5? You should be able to answer like that, 360. Do you see? You should be able to answer like that because you can multiply 72 by 10 and cut it by 2, right? Or you can cut it by 2 and multiply by 5, right? Or multiply by 10. Either way is fine. So then if you have 360, you subtract 270 from both sides. What is X? Okay. So guys, this was number 1 on the ACT exam. Okay, I'm just going to run through some problems on the ACT exam. That was number 1. How do you think about it? Fair, right? Okay. On your ACT exam, I want you to do me a favor. Number 1 to 15, number 16 to 30, number 31 to 45. Okay? What I want you to do is, I want you to, if you feel like you can't sit, if you feel like you can't sit still and do all 45 problems, try to do them in 3 batches. Does that make sense? The first set of problems, you should try and complete, if possible, in less than 12 minutes. And then maybe the next batch, you might do in like 17 minutes. And then in the last batch, you do what you have left with the time. Here's what I'm trying to do though. This is just an arbitrary arrangement. My point I'm trying to build is this. For your first 15 problems, learn to just go quickly. Why? Because they start you off a little slower. Does that make sense? You want to save up time for later, okay? Does that make sense? So make sure you practice. So number 1 to 15, maybe every day you take a few of those kinds of problems. And that's what we're doing now. We're doing some of the 1 to 15. By the time you get to the 40s, things are intense, right? Okay, very good. Let me go down to one more question. So on the ACT, here are the key categories of the problems. We talked about my list of what you need to know, but you need to know angles, and that's what we're going to do next, angles. So if you have a triangle ABC, and A and C are congruent, always draw, if you can, draw diagrams, okay? So let's see, A, B, and C. And they said A and C are congruent. What does that mean if A and C are congruent? They're the same, right? Okay, so if A and C are the same, by the way, that there's a relationship between their sides. We can talk about that later too. And the measure of angle B is 143.6. Can you guys please find the measure of angle A? What would we need to find the measure of angle A? I mean, we'll have to use the triangle angle sum theorem, right? Triangle angle sum theorem. What it says is that if I add up, let's call this beta, theta, theta, and beta, it should add up to what? 180, right? And so 2 theta plus 143.6 is 180. Now you guys know why we use alpha, beta, and so on, a lot of Greek alphabets, because who's the father of geometry? Euclid. Pythagoras is another guy. Do you see the point? These are Greek mathematicians. So you guys are kind of seeing the connection. Okay, what's theta? And you can feel free to put it in the chat too. What's theta? Theta. Feel free to say it out loud. Anyone? Theta? 80.2? Well, first you have to get 2 theta, and then you get theta. But go ahead. What did you say, Caleb?
18.2.
Oh, 18.2 you said? Yes. Okay, very good. So you subtracted this, and then you divided it by 2. Very good. Questions, thoughts, comments, objections on theta? Okay, so triangle angle sum theorem. Very good. Let's talk about matrices. How many of you are comfortable with matrices? Okay, very good. How many of you know what the determinant of a matrix is? So if you have a matrix like this, and I ask you to find the determinant, we would write it down like this. And it's basically this times this minus this times that. Okay. Here's what's interesting though about finding with matrices. One of the questions on the ACT, they just said 5 into -4, 2, 0, and -5. What do you have to do when there's a number outside the matrix? Multiply everything inside. Okay, you guys ready for your mind to be blown a little bit today? Why does AI work? Because of matrices. Matrices are the backbone of linear algebra, one of the main topics. And linear algebra is one of the backbones of AI. How many schools in the country teach linear algebra in high school? Almost none. Our schools are not keeping up with the AI revolution. Guess what you need to do? You gotta go learn linear algebra. Are you see what I'm saying? This is the season of life right now where you pull back on social media, you pull back on things that don't matter, and you amp up on the things that matter. And one of them is learn linear algebra. I promise you, you'll thank me someday. And you don't have to give me much. If you win the Nobel Prize, just send me 50 grand to help build a hospital in my village. But that's it. That's all I'm asking. 50 grand for a hospital in my village. Okay, I'm kidding. You can do 25. But my point I'm trying to make is this, guys. 10 years from now, watch what's going to happen to the curriculum globally. Linear algebra will be standard. But you already know. So I'm telling you what's going to happen before it happens because it's the backbone. Does that make sense? So please, everybody, linear algebra. This is from linear algebra. Matrices, this is right out of the ACT. It's also important for solving systems of equations. Have you guys ever seen like a system of equation? Like you see systems of equations, and by the way, if you saw a system of equation like this, what method would you want to use right away? Let's pause. Not all of us are prodigies, Caleb. I'm not substituting. I'm like, why did I hesitate about substitution? Because if you're trying to solve for x or y with that, you can have like fractions, So what am I going to use instead? Elimination. I'm going to eliminate a variable, right? So I eliminate, in this case, I could multiply everything by 2 and everything by 1. What am I eliminating when I do it this way? X. Everybody see that? So the methods for solving systems of equations is a part of a topic in linear algebra. Even though we didn't tell you that earlier on, but that's all you're doing. So here we're using elimination. We get 4x plus 6y is equal to 24. We get 4x plus 8y is equal to 15. And now we can subtract the second equation from the first. Everybody see that? So what's 6 minus 8? Negative 2y is equal to, what's 24 minus 15? And now we get y is equal to negative 9 over 2. Sorry, and then you substitute it back, right? Then you can substitute, and then you solve for x. Everybody see that part? Okay, so solving systems of equations, there's substitution, there's elimination, there's graphing, right? We can't have an ACT workshop without talking about this formula. Like, that should be illegal. Like, that's just illegal.
This is my favorite.
Right? You need the slope-intercept form. And, of course, you know what slope-intercept represents, right? When you have to graph a line, there are two ways to go about it. The first way always works, and that's table of values. That's great. But the second way, you use the slope and use the intercept. So y is equal to 2x plus 3. I can use a table of values, and you guys might be familiar with the table of values like this. If I know what negative 3, negative 2, negative 1, 0, 1, 2, 3, that's fine. I could do that. But guys, we ain't got time for that. Like, there's no time. You could do that when the function is weird, right? If I ask you y is equal to 2x to the third power, sure, use a table of values. But do you notice that, guys, just because you know how to shoot a 3, like, you get a steal, but that was a break. Stephen Curry's got a steal. And then nobody's on the defense, and he stops at the 3-point line. Well, he might do that. I know, he was doing okay.
He did that every time. That's a good shot.
That's a bad example, okay? Draymond Green, okay? Draymond Green. He stops at that. Is he going to stop at the top, or is he going to just go all the way to the rim and finish?
He going to pass Bob Steph.
That's what I'm saying. But part of the point is, as a basketball player with a high IQ, as you're getting to the basket, you're thinking, what makes sense? What makes sense? Does the table of value make sense for a linear function? It doesn't make sense. But can you use it? You can. See, the point I'm trying to instill in you is that just because you can do something doesn't mean you should. Only if it makes sense. And the ability to know what makes sense is really what begins to make you a better mathematician. Does that make sense? Okay, so now we go to our graph, we find the y-intercept, which is at 3, and then we use the slope, rise over run, right? Rise over run, rise over run, and we connect the dots, and we get ourselves a graph, right? And as far as the practical application of a graph, you want your life to have a positive slope, please? If it's on a negative slope, let's move it up to the positive slope, okay? Everybody get that? Positive slope, does that make sense? But can some things happen sometimes? Yeah, we get some downturns, but you get back up. That's the key. No matter what your story, let's get back on track. Does that make sense? Like today's a new day, okay? I want you going back and thinking, how can I stay going on the positive slope? And I don't stop growing because as long as there's life, we got to keep learning and growing. I'm going to end with a story. Mr. Silas, that was a lot of math. I don't know, some of these kids, I'm amazed they're still here. But I want to tell you guys a story from my...
Light work, man. Light work.
I'm going to tell you guys a story that really has troubled me because this is actually going to be very important for you. How many of you know of a company called the Kodak Company? About 60 years ago, if you wanted to take pictures, you used Kodak film and all of that, okay? I was reading a book on the plane on the way here yesterday, and it was very, very troubling. And here's what the book said. The author went to the University of Chicago, which I need to see that school sometime. He said, just because you're the best today doesn't mean you will be tomorrow. I'm like, oh boy. So you can't just get to a place and just like be complacent? No, you can't. When digital photography came, Kodak got in trouble. They lost market share. Are you guys seeing where I'm going with this? In the 1400s, before 1440, China was a big force in the global, and so on and so forth. But some things happened and an emperor changed things, and then China began to decline compared to their counterparts. Now that's changed today, but I'm talking about back then, right? So around 1450, what happened in Europe? The printing press. We got the printing press came, Europe started, more universities and things happened. So I gave you the example of China in the 1400s. I've given you an example of Kodak. And here's the point I'm trying to make, and you guys are even going to see it, for real. There's an AI company called Anthropic Claude. If you guys don't have Claude, then you got to fix that after this call. Talk to your parents. I need Claude, right? Just as a tool, but please, let me add, don't cheat yourself and don't deceive yourself. These are tools that serve a purpose, right? But you need to know how to use the tools because there are some companies that will not hire you if you're not AI fluent. I'm just being honest. Because AI fluency is now becoming like knowing how to use a computer. That's what companies are expecting. Unfortunately, the schools are still trying to figure out what to do. Okay, you still need to do your schoolwork, okay? You still need to do your best, but you also need to have a personal development track for your life. Guys, get what I'm saying? Just this week, I created a website, I vibe coded a website for my life. Guess what I was trying to do with it? It's called Personal Development for Amos. And I said, what areas of my life am I not exceptional in that I need to improve in? And then I started building classes for me. This is not for anybody else. Like, I need to learn some strategic thinking. I need to learn some negotiation skills. I need to learn, does that make sense? Like, I'm taking classes for my life, not for anybody's grades. You and I need to start thinking like that. What areas do you find that you're not as strong and that you need to learn? Build your own toolkit using things like Claude and so on and so forth. But what happened with Claude is their AI is the best in the world overall. They're the best, pretty much, right? And what's interesting is Claude is now buying out other companies that make graphics, for example. Because that was an area they were not the strongest in. I sent Mr. Silas a graphic yesterday. If I didn't tell him who made it, he would not believe it. It was Claude that made that graphic.
I don't believe it.
Claude is now making graphics just as good, and they're only going to get better. Why is this important? Because some of these companies are going to be massively disrupted. You're watching what happened to Kodak happen in real time. What should you do? Number one, being the best is no longer optional. You got to be the best in your craft. Everybody get that? Whatever your skills and your talent is, please be the best you can be. Number two, mathematics is your best friend till further notice. And English. I don't want Mr. Silas to think I'm saying anything about English. English is important. You speak English every day. The problem is you don't factor polynomials every day. Does that make sense? So you need to know math like you know your name. This is an investment. Hopefully you love it. So number one, for those on the call, I just wanted to recap it. Number one, thank you, Cameron. It was 18.2. Number one, guys, be the best you can be in your craft. Number two, be the best you can be in mathematics. Reach your math potential. I didn't say meet your state potential. Your state standard. I said meet your math potential. And if you meet your math potential, here's what I can guarantee you. You will do way better than any state standard in the world. Because the standards are not built on your math potential. They're built on a general overview. Does that make sense? Just a general average. You push yourself and invest. This is for your children and grandchildren or your relatives or however you want to think of it. Think of it, how can I be a blessing to people that come after me? I'm living in a time where I can do this. So please do your best. Study the maths the best you can. And just remember the third thing I said, which is part of the story I was trying to tell you. Just because you're the best today doesn't mean you should just be sleeping. Every day you go out and you give your bests and leave it on the court, as they say in basketball, right? You leave it on the court. Because if you get complacent, you're not going to be winning rings every year. You cannot be complacent. But here's the coolest thing, and then I'll end with this, I promise. Your portfolio matters when you apply to college, right? When you apply to college, it's not get the perfect score. I want you to do that. But here's the other thing I want you to do. Build your portfolio. I see a few of you young people here. How cool would it be if you guys are all working together and building out some things, building your portfolios, doing some research, collaborating, solving problems in your community? Wouldn't that be cool? Like, build your portfolio, guys. Because if it's about distractions and social media, AI is about to generate more content than human beings generate by next year. Oh, you know what that means? You could be busy on social media till next 15 years. This is my point. You can't do that, right? You got to be locked in. You have an opportunity of a lifetime.